Well, hey there, I'm Dr. Tom Ulrich, and I like to talk about leadership and engineering. But now that I'm on the faculty at Biola University, I also like to talk about Arduino. Hey, in this video, I'd like to talk about using your Arduino with the 7-segment display. Now, if you don't know what a 7-segment display is, it's this little guy right here. See him counting up there, 0 through 9. And the whole point of this video is to walk you through step by step how you can make your Arduino use that 7-segment display. All right, so as I mentioned, the plan is we're going to talk about how to use the 7-segment display that came with your Elegoo Super Arduino starter kits. If you don't have the Elegoo Super starter kit, the truth is most of the kits have something like this, and every 7-segment display I've seen is pretty much the same. So these concepts are going to be generally applicable. At any rate, by the way, I was kind of entertained. If you look at the user manual for the Elegoo kit, you see it's got the little, I just copied that out of the user manual, the thing in the upper right, sorry. You'll notice it's upside down. It's got the decimal point in the top. So, at any rate, by the way, I will not be using the 74HC595. That's in the next lecture. If you don't know what that is, don't worry about it. I'll tell you in the next lecture. All right, so let's take a look at what's in the user manual. This is the picture on the left is right from the user manual. The idea of a 7-segment display is that there's 7 segments. So you might say this is an aptly named device. At any rate, there it is there. The top one is an A, then on the right is a B, and below it a C, D, E, F, and then the G is the middle piece. And what I'm doing on the right is that's my hand. I'm holding the device, so you can kind of see, you can see real clearly how the pins correspond to the drawing there. Now, if you're trying to figure out which way is up, just look for the decimal point, kind of like the person in the user manual didn't do. At any rate, here's what the deal is. First of all, you got to figure out the pattern. You got to figure you're going to be controlling each of those 7 segments as if they're discrete LEDs. And so you got to slow down and figure out, okay, which segments are going to give me the number that I want. And I'm actually going to take you through it so you're not going to have to do the work. But kind of as a general engineering principle, that's what you do. That's what I did. Was, okay, how am I going to use this thing? The first thing I did is spend some time just sort of working it through. And here it is here. So at the top there, I've got the number 0. And it looks to me like it's going to take all the letters except for G. If you like the G, that's going to become an 8. And then for a 1 there, you see in red, it looks like that's just going to be segment B and segment C. And then to make the 2, it looks like it's A, B, D, E, and G. And, likewise for segment 3, see there, we're going to use A, G, and D for the crossbars and B and C for the verticals. And for the 4, you're going to use B, C, F, G. And for the 5, you're going to use A, C, D, F, and G. Now, right about now, you might even be thinking, wow, those are those old school numbers. Like, whoa, they used to make 4s like that. Well, why did they make 4s like that? Well, there was a time when the only way you could display data electronically was pretty much with a 7-segment display. So, that's kind of this is kind of like returning a little bit to your roots sort of thing. At any rate, for the number 6, you see I've got them there, and likewise for 7, 8, and 9, and of course 8 is all the lights lit. By the way, I mentioned these are all, it's as if you're driving 7 discrete LEDs, and there's really an 8th one if you have the decimal point. That's what DP is. Bear in mind that the power consumed by this device is directly proportional to the number of segments that you're displaying. So displaying an 8 is going to take 4 times as much power roughly as displaying a 1. All right, so what do we do next then? Well, in the software, we're going to have to figure out our pins. Now, that's pretty much what we always do, but we're going to use the digital outputs on Arduino to drive this directly. Now, if you're thinking, isn't there some kind of decoder chip? Yeah. That's the thing I was saying I'm not going to do in this lecture. That'll be next time. But for now, I want us to learn how to do it sort of discreetly. And here's the thing here. So as always in C, 2 slashes is a comment. And by the way, this is a great technique. This is something that is worth learning. Here's a case where a picture really lays it out pretty well. So see, I replicated the drawing in, this is called ASCII art. ASCII is the character set we use for when it's just, sort of old school letters. Any rate, so there it is there, and I've got H, I've got the little decimal point. I'm not using it, but I'm showing it there just for really for orientation. So what I'm going to do, you don't have to do this, you can do it any way you want, you got to keep it straight. I'm going to put segment A, I'm going to hook to digital output 4, I'm going to hook segment B to 5, segment C to 6, segment D to 7, 8, 9, 10. They don't have to be contiguous like that. You can have them be whatever you want. In fact, by introducing labels like this, it allows you to free them up, because maybe you realize, oh gosh, I'm using one of the ones, this uses several of the ones that are PWM outputs, and maybe you're thinking, well, you don't want to use it, you can use something else. But this is a scheme that allows you to sort of mix it up without having to do too much in the software. All right, so what we're going to do then is in the setup, we're going to have to enable each one of those pins as output. So there you have it, segment A through G, each one of them is going to be an output, right? Because that's what we're doing. It's just like driving an LED. Next here, I've got a function I'm calling write7seg. Hopefully that's for obvious reasons how I wrote that or spelled it that way. But what the idea of this function is, you pass the digits, so in this case it'll be 0 through 9 inclusive, and then it will turn on the various pins. Now there's other ways to do this. You can get all fancy and have arrays and really squish this down. But again, in this class, I'm assuming you have only minimal programming experience, so I don't want to get you all in crazy data structures. I'm going to do it sort of the very straightforward way. You may recall with the 0 there, so this is if the digit is 0, the only bar that isn't lit is the G, because that's the crossbar. If they were all lit, that'd be an 8. Take away the middle one, that's a 0. Likewise, so here it is here then, note what I'm doing is I'm using the switch statement. So the switch statement's kind of a fancy way to do if, so you don't have to say if digit is 0, then if digit is 1. You just say switch and you put the integer in there, in this case it's digit, and then you say case and then the number you're looking for, colon, then you have your code and you put the word break there with a semicolon, okay? So for a 0 then, zooming in on that bit of code, there it is. You see it's everything except the crossbar. And then there's my little Arduino kit on the bottom proudly displaying a 0. I'm pointing that out because I wanted to, I've seen a couple videos online now where they really seem to be riddled with errors, and I thought, well, let me make sure I'm not having bad code. So this code, I ran it, got it working, and then copied and pasted it. So at any rate, so here's a 1. So all you have to do here is light B and C. And so you'll see at line 55, it's low. Line 56 and 57, those are B and C respectively. Those are high, and all the rest are low. For creating a 2, that's the pattern you're going to need there. So you set them accordingly. And likewise for a 3 then, you're going to have everything but the ones on the left. So that's A, B, C, D, and G. And there's my 3 lit up. And then for doing 4 through 6, hopefully by now you've seen the pattern. There's the picture of my Arduino displaying it. You can see it does seem to work. And likewise for 7 through 9, you've got the exact same scenario where it just sort of replicates it. So hopefully you get that. It's a lot of work, and that's the downside of doing it this way. The upside is it's very intuitive and allows you to sort of really engage with the device. Now in our case statement, you had like case 5 and then a break, and case 6, then a break. What you do then is you put there at line 144, put default, and what that says is, if it's not one of the ones that I set above, then do this. In this case, I just turn them all off. You might want to do some illegal character, although the problem with that is sometimes people will see that and think, oh, gee, the device, the physical display is broken, and they won't realize, no, their code has a bug. Any rate, and then there's the end of the switch statement, and then the end of the 7-segment display. And by the way, you notice, putting comments to indicate the end of long batches of code that's definitely a professional approach. You can see here with this snippet, it really helps you understand the context. And that's pretty much why we do it. All right, so what are we doing in loop? Well, the bottom line is I don't know, it depends on what you want to do with your display. I thought it'd be fun if we just have it display a number, wait a second, display the next number, wait a second. And that's in fact when I first started this video, that's what it was doing. I looked down a moment ago and noticed the battery had depleted. So the downside of this device, it does take a fair amount of power, and I apparently depleted my 9-volt battery, but it wasn't like it was a new battery. At any rate, so here's loop. So I just said, okay, I'm going to have an integer I and have a for loop for I equals 0 to I less than 10. So that'll go 0 to 9 each time incremented. And then I pass I to write 7 segments. So first it'll pass a 0, the 0 to display, then it'll pass a 1, the 1 to display, and so on. So the software is fairly straightforward. It's a little bit cumbersome with all the having to have the big case statement, but it works. Now in terms of the hardware, this is pretty much the deal. You've got to hook up 2 pins to the ground, and it looks like that's pin 8 and pin 3. And, which one's pin 1? Well, what you do is look for distinguishing features. So you'll look at the device, you'll see where the decimal point is, and then you'll realize that, oh, okay, it's on the left. And by the way, usually with chips, when you lay them out, it's usually sort of, if it's laid sideways like this one is, it's usually the one on the bottom all the way to the left. So, and the way this one's oriented, the pins are like this and like this. So we'd say it's sideways. If it was like this, we'd say it's up and down. But that's in there sideways, even though it makes the numbers right set up. But that's how the pin numbering works. But, the real ticket is you've got a feature there, DP, decimal point, right there by pin 5. So you absolutely know where pin 5 is. Probably, what you want to do, these are LEDs. Like any LED, you want to do a current limiter. I'm recommending 330 ohms. If that's too bright, use something a little higher. I actually made mine with 200 ohm for the very practical reason that my Arduino kit came with a ton of 200 ohm resistors. The downside is, I extinguish my battery. So pretty much the power it draws will be proportional to the resistance. So, any rate. So here it is. So pin 1 there is going. So pin 1 here is the E, and so I've got them laid out where pin 4 is for A, pin 5 is for B, pin 6 is for C, pin 7 is for D, and so on. And so you can kind of follow the color squiggles there and see how I laid it out. You don't have to lay it out this way. That's just what I did. Logically, it has to be equivalent. It doesn't have to be laid out like that. Here's the board kind of zoomed in a little bit. You'll see my resistors are all kind of laying flat. I actually cut about 3/4 of an inch off, or maybe ½ inch off each side, so that I can lay them flat against the proto board. If you don't do that, they're all kind of hanging up there and they can touch, and it's chaos. So I just made the decision to lay them flat. And you can certainly see in this picture, one of the downsides of this approach is there's just simply a lot of wires here. All right, so as terms of final thoughts, here's how I would assess this. This technique does work. Like I just mentioned, it takes a lot of wires. It's a lot of wires, and it consumes 7 of your Arduino pins. There's only a finite number of pins. Do you really want to dedicate 7 of them to drive your display? And, you have to write a lot of software, so that's kind of the downside. So, if only there was some device that could simplify the connection, maybe something that would eliminate some of the software and use less wires, if only. That's why you want to watch my next video. At any rate, hey, I'm Dr. Tom Ulrich, engineering leadership guy who also now does Arduino, and I've actually got a whole bunch of videos on leadership. Leading engineers is my doctoral expertise. I'm an engineer by trade, but that's what I did my PhD, studying engineers. And I've got 40 videos on my website. You can go to Tom Arch Consulting for that. I'm also putting all these Arduino lectures. I was originally just giving these lectures in class, then coronavirus showed up, and then I'm like, oh, great, I'll post these too. So everybody, the 10 of you in the class, hello, good to see you. Hope you don't get sick. And at any rate, hey, and if you on YouTube, if you don't mind, could you do a like, or could you subscribe? YouTube recommends me more frequently as I get more and more subscribers, so I'd appreciate that. And by the way, if you want to leave a comment, I'll answer you personally. At any rate, thanks for listening. We'll talk to you next time.